One good thing about Python as a programming language, it is that it has very large community of developers and large amount of software development companies are using it. Some of them actually share their developments publicly in the form of libraries for Python. These libraries have a lot of different functions. So, for example, if you have some kind of database and you need to communicate with that database, you don't go to the lowest possible level. You don't create a TCP connection and start working with the database in binary requests. Instead, you'll first try to find any existing library for communication with that particular database, and then in large fraction of cases you will actually find such a library for Python. We have been already working a little bit with libraries, even though I haven't declared it openly. For example, when we imported those mathematic functions from math library, when we run import math, we actually use one of the standard libraries that are included in the Python. And math is now an object that we can use to calculate some functions that are built into that library. So this is quite straightforward. Other libraries that are not standard for Python, you will not be able to import until you have them installed on your machine. The math library comes with any Python version, and so is, for example, a pathlib that is useful for handling different file and directory paths appropriately in Python. For example, if we import pathlib and type p equals pathlib.path and execute this line, we now have an object p that contains path relative to the application folder. This construct creates an instance of an object that references current location or some file in your current location. And if we create one, we can operate on that path. We can, for example, resolve it. And now it will indicate the correct full path from the root of our hard drive or our file system. We can also append some files to it. So if we do, for example, this, and type slash, and then follow it by some file name, if we execute this, we see that the some file references has been added to the path. Actually, it doesn't really know at the moment whether this is a real file or a directory or even if it really exists. It does not care at this point. It is just a representation of the reference to that particular file. And with this, you can do a lot of useful things around the files. Alternatively, instead of importing the whole library, you can import individual functions. To do that, you use syntax from library name import functions that you are interested in. For example, if you do it this way, then each of these functions will be available under its own name, and you can call them. These are also objects that you can interact with, and we will get to that a little bit later in discussion of object-oriented programming with Python. Sometimes your program will already contain some functions that are named, for example, sign, or it might be a name that is reserved for some special purpose in your program. In such cases, you can also rename your objects. For example, in this way. This will import the scene function from math module and put it under variable math_scene. And if we call math_scene and pass 5 as an argument, then we will see the expected result. You can see that it is the same library and it basically will do all the same functions as normal scene. And these are two most popular standard libraries. A bit later we will discuss how we can operate and install additional libraries, but right now let's talk how we can create our own, because libraries and modules and packages are extremely useful tools when you are writing your own software. Normally, when you are starting a new project, you might start with one file. You will have one main function that will do something, and then you will start repeating some code and you will start extracting it into some new functions, and then you will end up with a very, very large file. And at some point you will decide it's time to extract part of those functions that have some specific purpose into a separate module. So let's do that. Let's go with the example for basic input-output, and let's convert the whole calculation into a function. So we proceed by defining the function, and let's call it run, and it will have no arguments. And if we execute this now, it will not run this function. Instead, it will just define it. Now let's first move this function code into a new module. To do that, we will copy it, and we will create a new file using touch command in terminal. We will name it mymodule.py, and we will open it with standard text editor, gedit, and we'll copy paste it here. Save and return to the Jupyter notebook. Now we can use import statement to import our my module, and as you can see, it imports it successfully. And inside this my module, we now have run function. And if we call it using round brackets, it will start executing the same code as we had before. Now, how this works under the hood? So when we import a module, Python looks up for a mymodule.py based on this mymodule, what we have decided to import. And it first runs this module as a file, as if it was a script. So for example, if we were modify this and add a print statement at the end and try importing this module again, we will see that message. Unfortunately, in this case, we don't see it because we have already imported my module once. And in order to see the updated version, we need to restart our kernel. And as you can see, now we have this I have been executed line printed out. And if we run it second time, it does not do anything anymore because the second time it will not be executed. Now, in the same way as we did for math, we can import the run function directly from this module using from my module import run function. And now we still have this function here, even though we have not executed this line or this cell after the start of the kernel. And we can call this function again, and it will still execute things. So this is quite straightforward. You don't have to import only functions in this way. You can also import individual variables. For example, let's declare some constant inside this module. Let's name it some value. And please note that I'm using all capital variable name because in Python this is convention for constants. It does not make this variable a constant, but it is a conventional way to explain to user of that variable that it is expected not to be changed. And let's assign to it some value, for example, 50. Now we can restart our kernel to refresh our my module instance. And first we can import module in whole. And now we can see that my module dot some value returns the correct value 50 that we have assigned to this constant. And in a similar manner, we can use from import syntax to import that some value directly. And we will have some value imported as a variable in our case. One important thing to notice here is that, for example, if for some reason we were importing a value that have been changed during the execution of this script, we will only see the latest value of that variable. So let's save it here and restart kernel and import some value once again. And as you can see, it returns 250. So all these assignments have been removed from the module. So if you have a script and you try to import it as a module, then be aware that the script will be executed first, and only then it will appear as a module in your program. And this is sometimes a desired behavior. For example, if you want to indicate the process of loading a script, but sometimes it is not. And then you want to have a block that looks like this. And we're going to use correct quotes here and colon at the end. Now, whatever we type inside this if statement will only be executed under certain specific conditions. Specifically, it will be executed only if it is run directly as a script, because only in that case, this special variable underscore underscore name underscore underscore will have value underscore underscore main underscore underscore. In other cases, it will be named as name of the module. Let's test this. So first of all, we restart kernel again, and we import my module. And as you can see, it has not been executing print statement. And in the diagnostic message that we have added, my name is my module. So it is equivalent to this string. Contrary to that, if we were to just type Python 3, my module, py, then you would see that my name is underscore underscore main underscore underscore, which is what we expect. And in such case, print have been executed. Okay, this basically is everything that you can do with modules. So you can have functions and variables declared inside them, and you can import both functions and variables from the modules into other modules or into your scripts or into your Jupyter notebooks. It doesn't really matter. Now, what are packages? Packages are basically collections of modules in your program, packages look like folders, but not every folder will be considered a package by Python. In order to be considered a package, the folder should contain a special file. The name of the file should be _init_.py. Let's make one. So first we type mkdir to make a folder, and we will name it mypack, and we'll change dir to mypack. And inside this, we will just create an empty file. And this is enough to create a package in Python. So let's move our module from the root, from the same folder where our Python notebook is located, into our package. Now we have two files, the init.py and mymodule.py. How we import module in such case? In order to import a module from a package, you need to use import package name dot mymodule as your import command. And as you can see, it has been successfully executed, and the name now correctly lists also the name of the package into which we have submitted this module. Now we can reference it in the same way as we did before, except that we have to prepend our module name with the name of our package as well. So if we want to run the function, we need to type mypack.mymodule.run and execute it. And then it runs. Okay. Packages can also include other packages. So if you will have multiple levels of folders, and in each of them you will have __init_.py file, the Python will correctly recognize those as nested packages, and it will allow you to use multiple levels of referencing. So you will have mypack1, then .mypack2, and so on. The good thing about this structure is that it allows modules to reference each other, and it allows modules to import each other in a more repeatable way. But we will talk more about that on practical exercises when we will have some more complicated structure in our program.